That's usually the biggest problem. There you go.
Press right on the right button, I guess, right? Okay, cool. Yeah, Thomas Kramer, hello. Nice. Glad you're here and listening to that more technical discussion actually, but hope it's still relevant for you. So today we're talking about single API. You may wonder, API, what's this about? What the heck is that? In the end, API has become, since probably, I don't know, a decade or something, has become a very, very crucial component for the success of your business. So API is a technical interface between programs, which means you're developing a component or an application that is being used by other applications or programs. They have to communicate through this API. So it's really important that the API is well designed, that it's understood by the programs of the other components, that they can communicate correctly and well. And that, of course, is something that should not, change significantly over the days, because then the other communication partners of your programs have to change their side as well. So it's really important and crucial, and especially since the rise of microservices. Everybody talks about microservices, building from a huge monolith kind of application into individual components. That makes your program into small pieces that have to communicate to each other. For those communications, an API is also very, very crucial and has to be done efficiently, so that the developers of the other components, really have to not have a huge learning curve and all these things. So API is what this is about. What we're talking about here now is a single API on top of video codecs. Of course, there's very many different implementations of video codecs, H.264, HEVC, VVC, AV1, all these, which means there's also implementation differences in APIs. There's an API from a vendor like MainConcept. There's an API for the same codec from a vendor like Intel or NVIDIA, have a different API again. So this makes it a huge engineering effort for companies who are actually building the services or the applications for video encoding, transcoding, streaming, to handle all these different APIs. If you're an engineer, you will know what I'm talking about, because then you have to deal with different vendors, you have to deal with different APIs, you have to probably have issues, even interoperability between those APIs, and that's really a nightmare to handle. What we are integrating here is together with our software codecs. So we, as a implementer of video codecs, we have our own implementation that we have done for the standard. But we're integrating with our API, so it's a single entry point. We're integrating available hardware codecs that you might find within your into your hardware. Which means if you're integrating with the single API that we are offering here, you can automatically access the hardware codecs that are potentially available in your computer system, which takes away a huge amount of engineering effort from your engineering teams. So that helps, because they have to deal just with a single API. We take all these details to handle the encoding, decoding, and processing on the different kinds of hardware that you might find in the system. So just, scaling it up, you use one SDK and one API instead of 4. In this example here. You have more GPO options, because typically when you develop, let's say, an integration with the codec from Intel, for example, you might have all the kind of features that are available in the specific Intel codec. But once you actually want to use and leverage a new hardware codec from NVIDIA or from another vendor, then suddenly you have to integrate them again. With this API, you just have all options available that are basically here in the market from those 3 vendors, plus the software codec, which typically has most features, has also most best quality, but in the end you would have to deal with them separately. And this is a single API. So with the software options, that's also available under this API. You will see all the features that you might be missing in the hardware vendors codecs. But of course, hardware codecs are super efficient in terms of speed, super efficient in terms of power efficiency as well. So that's, of course, their benefits that you see here. Why would that be, let's say, applicable for an IP workflow? Since we're here at the IMS and EMVA booth, so we will talk about that also in more kind of concrete examples later. So if you're a software vendor, you're developing, an ingest product or an application or a service, or you're building a transcode application for VOD or for live content, or you might actually do a live encoder, building an application or an online service for live encoding. This is exactly what you will probably face when you're an engineer for that, because you will have to deal with the different APIs. With the solution of a single API, you can have all the flexibility either of the software codec or the hardware codecs that would fit what you actually need. So in terms of if you're looking for density, a hardware encoding is definitely the choice of, for you, because in the end you could have more live streams, more channels on one server, while if you're focusing on a VOD in best terms of quality, then a software codec, maybe even a chunked software encoding is the choice then for you. So with a single API on top of all these vendors, that's exactly the kind of burden that takes away a lot of engineering work from you. So a few examples put together here. In this case, you're looking at a broadcast server. You have, live ingest. In this case, it's an JPEG streams from all the cameras that you have maybe in the field or in the studio. You're capturing them all. In the end, you have to process those servers that are those feeds that are coming into your server. So capturing them and then, of course, bringing them to disk. So you're storing them in a format that doesn't lose too much quality, but also doesn't waste, all your disk. So you have to compress it. So passing that into an encoder is just the next step that you usually do after capturing. So capturing many live streams, that's quite an effort for the actual CPU and processing power. Getting that through one API at least takes away all the engineering work that you need to do to handle all these different encoding vendors. So this is a logical step for you. So you're focusing on just one API and have to deal with just the single kind of vendor. Looking at, let's say, the encoding options, again, it depends on your case where you're looking for. If you have so many streams coming into your server that you cannot handle with a single software encoding, you may then just choose, for example, one of the hardware vendors if it's available in your server, and that, of course, gives you better efficiency. So in terms of why you do that, you, of course, in the end have a smaller file size. You must compress, right? Even though you're processing the file after it's been captured, you process that into a file format that has a smaller size. With both options, GPU and software, you also automatically have the formats that you may need, depending on either your kind of workflow that you're working on or your further processing. There might be different variations within the H.264, HEVC, or other flavors of codecs that you will have to deal with. So the options that you have with just the one API on top of so many different codec implementations is just, really enormous, and you can have, all these implementations available. Because of the hardware vendors, you also have the option to have more ingests. So it's really the multi-stream ingest typically becomes possible only if you're using hardware codecs. Otherwise, you have to spawn on many different servers. But here you have one server using hardware codec, and you can have multi-stream ingest. Looking at another example in the live production. So you have already, from the previous slide, you saw, okay, you have all your content in your on your server, so it's already compressed, you have it there, but you may do some effects, replays, or overlays in that before you actually broadcast them live. So before sending them out, you might send them to some kind of live production tools. From your server then, you have to transfer them. So this is then also typically done with just IP workflow protocols or IP workflow formats. So decoding those files that you have here on the disk on your playout server, you would then automatically convert them again into some streaming protocol and streaming low latency codec to do the actual live production here. So overlays, replays, creating some banners and things like that. So this also needs some kind of processing on the server here again. And again, if you imagine there's also the actual ingest and capturing happening here as well, then again, you want to send those files and have to process and decode again. That makes your next step where you have to think about really what is the efficiency that you have to deal with here. if that's one server, then you may have to consider really different options for hardware codecs as well. Again, that's not an issue. The issue becomes if your engineers suddenly complain about all these different APIs from the vendors that they have to deal with. So really integrating that into one API is the key point here. Last part, what's done with all the content that you have stored and prepared on your servers, you want to send them out. You want to deliver, you want to then send that over broadcast or over an OTT streaming service here. So you typically create many renditions out of that. What means, depending on the devices that you want to serve to, it's an H.264 rendition, it's an HEVC rendition, it's an AV1 rendition, and that is a lot of encoding that you have to do when you're dealing with different devices. So again, looking at what you need to process on that server, that becomes a very high load on those machines. You can either distribute that on many servers or on cloud instances, or you keep that within a few only servers and utilize hardware codecs and a mix of software and hardware codecs depending on the capacity that you need, on the bitrate ladder that you have to fulfill. But using that again for your engineering purpose, you do really have to do that within a single API, which gives you all the benefits of automatically having access to all the different codecs in software and hardware. So this very quickly adds up to something that you cannot really handle on a single server anymore unless you're leveraging hardware codecs as well. So looking at the actual really pain points that we solve with such an approach of a single API, you really get into multi-stream encoding. So handling more streams that you can with just a pure software implementation on a single server, leveraging through the same API, through the same implementation, as many of the hardware vendors and software vendors that you can mix into one implementation. That really gives you more flexibility and you can handle more streams on one server, which in the end saves you not only the engineering time to handling with the different APIs, but also saves you the actual server capacity that you need for that. In the end, avoiding having to go through all the support forums or on websites and documentation for the different vendor APIs is a huge kind of benefit for a single API and single entry point instead of having to go through all the others. So really a huge cost saving that you have on engineering side, and the combination with software and hardware codecs gives you on the actual production as well a cost saving there. Speed is always something that you may look at. It depends on the use case. If you're in VOD transcoding, then you have to focus on the actual quality of the encoding as well. You can mix that with the hardware processing as well, but in the end, your case is often that you have to, deliver something as soon as possible, maybe a highlight in a live sports event. That highlight must be transcoded, maybe with some additional information overlaid. So processing speed is always crucial. So you have to balance between speed and quality in terms of hardware versus software codecs. Doing that within the single API is just super simple. Otherwise, you deal, again, with different vendors' APIs, different hardware implementations, and different codec implementations. So that's the key point of having a single API on top of all these implementations. Cool. Last thing, really a summary. If you're looking to integrate video encoding, video decoding, you have very different use cases. You have demands, requirements that may really be from a low, a high kind of speed encoding or a real-time encoding, or just you take time in order to have the best quality encoding. So those requirements depend on what your product may look, what your requirements for the customers are. So having this all the features and options within the single API makes your product much more flexible than it was if you would have to deal with everything separately. So engineering cost saving, time saving, faster to the market because you're dealing with just a single API. Using more options within this API across GPU vendors, hardware vendors, gives you all the differences under one API, because there's a vendor that does support certain features in the codec, but other vendors do not support that. So those options you always have to deal with. Making that accessible, you don't have to deal with the details, but using that through the API makes it very easy. And always there's the software implementation that gives you all the features, that really has the highest quality and all the features. But of course, in terms of speed, it's not as efficient as a hardware codec. Again, this is the trade-off that you have to make depending on your customers and depending on the requirements that you have to give yourselves as well. So, as a summary, getting the video codec implementations under one API really saves your engineering time, really saves your production cost. That's a crucial point that we're showing here. And if you have any further questions, I'm happy to answer. Yeah, please.